Welcome back to our Algebra 2 series. Today we're looking at absolute value examples, and in this case we're working on the centering method that we started in class and we're going to continue today, where we use the number line to help us solve some of these interesting absolute value problems. And the first thing we saw with one of these guys is that we have to take that 2x minus 3 and identify the center of our graph, which represented, if you recall, it represented like the thermostat for us. We called it a thermostat. Well, in this case, we didn't want to have a 2 in front of x because the 2 affected the distance. And so what we did was we took the 2 out as a separate term, and then we ended up with x minus 3 halves because you factor a 2 out of a 3 and you get 3 halves, and then that became 5. And once you well, it stayed 5, I should say. And then we can go ahead and divide by the 2. So our preparation, what I call our little algebraic preparation for this, comes out to be x minus 3 halves inside and then a 5 halves over here. The absolute value of 2 is 2, and we can divide. When we got to this point, we had to write it in words. So we wrote all x that were less than or equal to 5 halves units from the center, which came out to be 3 halves. Now, of course, we get the 3 halves because we're asking ourselves, for what value of x will we make that 0? Will we make that inside 0? The items to the left of that will produce negatives and then be negated. Values to the right of that will be positive, and then the absolute value won't do anything. Well, if we graph what we've actually written, we see that all values of x less than or equal to 5 halves units from 3 halves. That means we want to go a distance of 5 halves in both directions. To the right, we would end up with 8 halves, or 4, and in the opposite direction, we would end up with negative 2 halves, or negative 1. And we're looking for all the values that are less than or equal to that, so that means we want the ones that are closer to our center. So what you see in graphing form there is the answer, and then of course we would end up writing this in interval notation to indicate x on all the values here now from negative 1 to 4. And we would just box that as our solution. So we're indicating all the x values on the interval from negative 1 to 4 will answer the inequality properly. Well, that was great in class. We saw that that worked pretty well. But then when we come across something like this, and we say to ourselves, that's a bit of a monster there because it's compound, but it can be handled the same exact way. It gets a little bit more complicated in the wording, but I think we can handle this. We know that this is an and situation because we're talking about our inequality being between two numbers. So in this case, I would write 3 is coming outside. In this case, it's an x plus 2/3. And we're still between 7 and 2. Of course, notice that the 2 is equals and the 7 is not. Now, when I divide by the 3, which is the absolute value of 3 is 3, now that guy is going to be as a denominator, 2/3, and then the absolute value of x plus 2/3, and then 7/3. So we have to divide in all three places. And after a while, we'll notice we'll just go ahead and divide by the 3 all the way throughout without doing this additional step right here. We'll just skip that step entirely. Now, the key to this, of course, is to write it in words. We have identified that the center of our graph is going to be at negative 2/3 because that's the value that would make that 0. And we have two different distances to deal with here. So we would write all x, and I'm going to write it this way, which is going to be kind of strange, all x that are between 2/3 and 7/3 units from our center, which was negative 2/3. Now that's going to be strange because when I do the number line now, it's going to take a little bit of work. I have to really think about what I'm doing here. But it all starts with the center, which would be negative 2/3. Negative 2/3 is here. And I'm talking about all values of x that are, let's see, greater than or equal to 2/3. So I'm going to move in this direction 2/3 and in this direction 2/3. And that would be 0. And this would be negative 4/3 and equal to that. Now the values have to be greater, so that means they're going to go in that direction and that direction. And then less than 7/3. So if I have now the second one, let me put it in a different color here. That was 2/3. Now I'm going to go 7/3. And this one's going to go 7/3. Okay, and just for the sake of clarity here, this is the 2/3 going in this direction and 2/3 there. Okay, so when we finish this out, moving 7/3 to the right from negative 2/3 puts us at positive 5/3. And going to the left gives us negative 9/3. Oh, maybe I should just write negative 3 there, since that's what that is. Negative 3. I'll put it in black now. Negative 3. And then I'll put this one in black. This is going to be 5/3. And these are open circles because they're not included, and that's because of this sign right here. And notice then that we get this and this. So we have two different parts on the graph. And as we answer this one in set notation this time, x such that x is going to be between two different items. So first of all, x is between negative 3 and negative 4/3. Or, that's a comma, or x could be between, in this case it's greater than or equal to the 0, because notice that this is flipped around now, and less than 5/3. Now, isn't that a sweet little problem? Because it produces such a unique answer, and it didn't look like we'd be able to do that until we worked on it by these distances. So there you go, a little introduction to the centering method.